In last class, we have solved some problems of electrochemistry that were asked by JEE Main. Now we are going to solve some more problems of electrochemistry which were asked by JEE Main in different years. We have discussed 13 questions in previous class. Now we are going to discuss next questions. Question number 14. And that question is the standard EMF. The standard EMF of a cell involving one electron change is found to be 0.0591 volt at 25 degrees Celsius. The question is the equilibrium constant of the reaction is Faraday constant is given as 96500 Coulomb per mole and R is equal to 8.314 joule per mole per Kelvin. These are the data given. This was the question asked by JEE Main in 2004. The options are 1 into 10 power 10, B option is 1 into 10 power 5, C option is 1 into 10 power 1 and D option is 1 into 10 power 30. These are the four options given. In this question, it is told that standard EMF of a cell. We know that E naught is equal to 0.0591 divided by n log K equilibrium. This is the relationship. You must be knowing that. This is the relationship at 25 degrees Celsius. 25 degrees Celsius is mentioned. 2.303 RT by F value is 0.0591. So E naught value is given. E naught value is given as 0.591, not 0.0591. 0.0591. Number of mole of electron is given as 1 log K equilibrium. It means that log K equilibrium 0.591 divided by 0.0591, that is equal to 10. So K equilibrium is equal to 1 into 10 to the power 10. This is the relationship of equilibrium constant. We can easily see that this is the relationship. You know that E naught cell is equal to 0.0591 or sometimes it is written as 0.0592 divided by n log K equilibrium. So this is the question that was asked by JEE Main in 2004. The next question that was asked by JEE Main is question number 15. In this question it is told that the limiting molar conductivity lambda naught for NaCl, KBr and KCl are 126, 152 and 150 Simon meter square mole inverse respectively. The lambda naught value for NaBr is, again this was the question asked by JEE Main in 2004. The options given are A option is 278 Simon This is centimeter square, not meter square. Simon centimeter square mole inverse. B option is 176 Simon centimeter square mole inverse. C option is 128 Simon centimeter square mole inverse. And D option is 302 Simon centimeter square mole inverse. These are the four options given, and we have to calculate lambda naught value for NABR. You must be knowing the Correlation law. So from RAUCH Correlation law, we can easily see that lambda NABR will be equal to lambda NA plus lambda BR minus. Now we can add some ion or subtract some ion depending upon the data. In data, lambda naught value of which one is given. You are seeing that lambda naught for NaCl is given. So I am adding Cl minus. So I am adding Cl minus, lambda naught Cl minus. I have to subtract also Cl minus, so I am subtracting also. Plus lambda naught Br minus. In data it is given that lambda naught of K plus. So I have to subtract lambda naught of K plus again. So we can write this expression and this one. You can see that this plus this is going to be equal to lambda naught NaCl. And then again this is lambda naught Kbr minus lambda naught KCl. And if you look at the data given, that is equal to 126 plus 152 minus 150. And that is equal to 128 Simon centimeter square mole inverse. So the correct answer is C, which can be easily calculated by using Correlation law. The next question that was asked by JEE Main is question number 16. That was again asked in 2004. The question is in a cell that utilizes the reaction zinc solid reacts with 2H plus aqueous to form zinc 2 plus aqueous plus H2 gas. Addition of H2SO4 to the cathode compartment. So 4 to the cathode compartment will, A option is increase E and shift equilibrium to the right. B, lower E and shift equilibrium to the right. C option is lower E and shift equilibrium to the left. And D option is increase E and shift equilibrium to the left. These are the four options given. This was the question asked by JEE Main 2004. If you look at the options given, you can easily see that zinc is reducing H plus into H2. If we add H plus is getting reduced. If we add H2SO4, it means H plus is adding. If we add H plus, reaction will move rightward. And if reaction will move rightward, then EMF will increase. So the correct answer will be A. Addition of H2SO4 to the cathodic compartment will leads to reaction in forward direction, and hence EMF will increase and equilibrium will shift toward right. Question number 17. This is question number 16. Question number 17 is the E naught value M3 plus M2 plus 4 chromium, manganese, iron and cobalt are minus 0.41 volt, plus 1.57 volt, 0.77 volt and plus 1.97 volt respectively. For which one of these metals, the change in oxidation state from plus 2 to plus 3 is easiest, which will easily oxidize. It is telling, question is telling that which will easily oxidize. This was again question asked by JEE Main in 2004. In question, the reduction potential data of different metal is given, and it is asked that which of the following metal will easily oxidize to plus 2 to plus 3 oxidation state. And you know that oxidizing power is directly proportional to reduction potential. It means that reducing power is inversely proportional to reduction potential. Reducing power is inversely proportional to reduction potential. And if a species is getting oxidized, it means that that species has greater ability to reduce other. And if they have greater ability to reduce other, it means they have lower reduction potential. So if you look at the reduction potential data, among these, then minimum reduction potential is for chromium. So chromium is minus 0.41 volt. So minimum reduction potential is for chromium. So chromium has highest reducing power and hence greater ability to oxidize itself. So chromium will be the correct answer. You can easily understand that. If a species has ability to reduce other, then this species will oxidize itself. And by using this concept, I have answered the question that chromium has minimum reduction potential data and hence it will easily oxidize itself and reduce other. Question number 18. For a spontaneous reaction, del G equilibrium constant and E cell are respectively, A option is negative, greater than 1, negative. B option is negative, less than 1, negative. C option is positive, greater than 1 and negative. And D option is negative, greater than 1 and positive. This was the question asked by JEE Main in 2005. Easy question. For a spontaneous reaction, you know that del G is, for a spontaneous reaction, del G is less than 0. So minus NFE is less than 0. This implies that E is greater than 0. So del G is negative and E is positive. Again, del G is equal to, if we relate at a standard condition from this one, I think del G negative and del E positive is given only in option D. So this is the correct result. If you relate del G not by log K equilibrium, then it will come that log K equilibrium will be greater than will be positive, and hence K equilibrium will be greater than 1 if we assume at a standard condition. Question number 19. Question number 19 is the highest electrical conductivity. The highest electrical conductivity of following aqueous solution is of A option 0.1 m difluoroacetic acid, B option is 0.1 m fluoroacetic acid, C option is 0.1 m chloroacetic acid, and D option is 0.1 m acetic acid. This is the question asked by JEE Main 2005. Electrical conductivity we have been asked. Electrical conductivity is directly proportional to number of ions, concentration of ions, and concentration of ions is directly proportional to a strength of electrolyte. If you look at the options given, we have given 4 acid, and in first option is 2 fluorine is attached to acetic acid, second is 1 fluorine is attached to acetic acid, third is 1 chlorine is attached to acetic acid. And you know that as acidic strength is increased by acceptor group. Halogens are minus I group, minus I effect is produced by halogen, and hence difluoroacetic acid has highest acidic strength. So a strength of electrolyte is maximum in this case, and hence concentration of ions will be larger, and that's why electrical conductivity will be more. So this is the value of electrical conductivity, highest electrical conductivity for 0.1 m difluoroacetic acid. Now next question is question number 20. In this question it is told that aluminium oxide Al2O3 can be electrolyzed at 1000 degrees Celsius to furnace aluminium metal. The reaction at cathode is Al3 plus, except 3 electron gives aluminium. To prepare 5.12 kg of aluminium metal, by this method we require, A option is 5.49 10 to the power 1 coulomb, B option is 5.49 10 to the power 4 coulomb, C option is 1.83 10 to the power 7 coulomb, and D option is 5.49 10 to the power 7 coulomb. These are the options given. This was the question asked by JEE Main in 2005 again. We have to use Faraday law. Faraday first law told that W is equal to Z into Q, and if it is told that 5.12 kg of aluminium has to prepare it, so this is 5.12 kg, and that will be equal to 27. This is Z is equal to gram equivalent weight divided by 96500 into Q. So 51200 gram, that will be equal to 27 by 3 divided by 96500 coulomb into Q. So Q will be going to be equal to 51200 into 96500 divided by 9. This is the value. So if we divide it as, so it will be going to be equal to 5.12 into 9.65 into 10 to the power 8 divided by 9. This is the value 5.12. This is 5120, not this one. So this is 10 to the power 7, and in this way you will have option of 5.49 10 to the power 7. This is the data. This is going to be equal to 5.49 10 to the power 7 coulomb. This much amount of electricity is required for production of 5.12 kg of aluminum metal by this method. Next question, we can easily ask that. Question number 21. In 21 question number, for different electrolyte, just like KCl, KNO3, HCl, NaOSe and NaCl, lambda infinity m molar conductance is given as 149.9, lambda infinity m is given as 145, lambda infinity m is given as 426.5, lambda infinity m is given as 91, and lambda infinity m is given as 126.5. From this data, calculate lambda HOAC using molar conductance of above electrolyte. A option is 217.5, B option is 390.7, C option is 552.7, and D option is 5.71.2. This is the question asked by JEE Main in 2005. So if we going to solve this problem, we have been asked lambda, we have to use Cauchy's law, and this is nothing but lambda H plus and lambda OAC minus. Now I am adding Cl minus here and then subtracting Cl minus again. I am adding Na plus here, OAC minus plus lambda infinity Na plus, minus lambda infinity Na plus. And if you look at the option given, then you will have lambda infinity HCl plus lambda infinity NaOAC minus lambda infinity NaCl. So you will have lambda infinity HCl is equal to 426.5 plus lambda NaOAC is equal to 91 minus lambda is this one for 126.5. So if we calculate, this is the data given, this is the data, sorry, this is 426.2, not 426.5. So if we use this one, so this is going to be equal to 7 and this is going to be equal to 517.2 minus 126.5. This is going to be equal to 7 point. Now this is going to be equal to 6, that is equal to 0. This is equal to 1, 9, and this is going to be equal to 390. So 390.7 is the correct answer. We have to use the molar conductance data of HCl, NaOAC and NaCl. This type of problem we have solved earlier also in this class. Question number 22. Question number 22 is, which of the following chemical reaction depicts the oxidizing behavior of H2SO4? Means in which reaction H2SO4 is acting as oxidizing agent. This was the question asked by JEE Main in 2006. A option is NaCl react with H2SO4 to give Na2SO4 plus HCl. This is clearly an acid-base reaction, nothing else. I think displacement reaction, not acid-base reaction. PCl5 react with H2SO4 to give POCl3 plus HCl plus SOCl2. I am not writing the balance reaction because that is not required. HI reacts with H2SO4 to give I2 plus SO2. This is the oxidation reduction reaction. You can easily see that. D option, CaOH whole twice react with H2SO4 to give CaSO4 plus H2. Among these options, you can easily see that C is the correct answer. C is the correct answer, where H2SO4 acts as oxidizing agent because it is itself reducing +4 to +6. Sulfur is reducing from +6 oxidation state to +4 oxidation state, and hence it acts as oxidizing agent here. Next question, question number 23. Question number 23 is, the molar conductance at infinite dilution for NaOAC and HCl at 25 degrees Celsius are 91.0 and 426.2 Simon centimeter square mole inverse respectively. To calculate lambda infinity m of HOAC, the additional value required is, this is again question asked in 2006. A option is lambda NaOH m NaOH, B option is lambda m NaCl, C option is lambda m water, and D option is lambda m KCl. We can again easily solve this problem. We have to calculate HOAC, molar conductance of HOAC. This will be equal to HCl, and if we use lambda NaOAC, then extra ion is Na plus there and Cl minus here. So we have to subtract a lambda m of NaCl. So this is the data that we require to calculate lambda m of HOAC by using lambda m of HCl and lambda m of NaOAC. We have to use this one. We have to use this one to calculate lambda m of NaCl. Lambda m of HOAC, lambda m of NaCl is required beside these two. This is a very easy question that was. Next question is question number 24. This question is resistance of a conductivity cell filled with solution of electrolyte of concentration 0.1 m is 100 ohm. the conductivity of this solution is 1.29 Simon meter inverse. Resistance of same cell when filled with 0.2 m is 520 ohm. The molar conductivity of electrolyte, of concentration 0.2 m will be, A option is 1.24 10 to the power minus 4 Simon centimeter square mole inverse. B option is 12.4 10 to the power minus 4 Simon centimeter square mole inverse. C option is 124 10 to the power minus 4 Simon meter square mole inverse. This is given as meter square, not centimeter square. And D option is 1240 and 10 to the power minus 4 Simon meter square mole inverse. These are the data given. This was the question asked by JEE Main in 2006. Look, for 0.1 m solution, resistance is 100 ohm and kappa is 1.29 Simon meter inverse. I am using data in centimeter inverse. I am using length as centimeter inverse. So if this is in meter inverse, then it is centimeter inverse. This will be going to be equal to centimeter inverse. Meter is replaced by centimeter, so this will be going to equal to 1.29 into 10 to the power minus 2 Simon centimeter inverse. So if you look at the data relationship, you know that conductance is equal to, or resistance is equal to resistivity into L by A. Resistance is 100 ohm. This is 1 by 1.29. This is 1 by kappa, conductivity, L by A. So L by A, this is cell constant. Cell constant will be going to be equal to 1 by kappa into 100. And that is going to be equal to 1.29 centimeter inverse. This is 1.29 centimeter inverse. Now we have to calculate, if we have used the L by A, then again for 0.2 m solution. For 0.2 m solution, again R is equal to rho L by A. Now L by A will be same because cell is same, 420 ohm. Rho is equal to 1.29. So this is equal to rho is equal to 520 into 1.29. And rho is this one. So kappa dash, rho dash, R dash I am using. Kappa dash will be equal to 1 by rho dash, and that will be equal to 1 by 520 into 1.29. We have to calculate molar conductivity. So molar conductivity is nothing but kappa dash divided by molarity into 1000. This is the relationship. I am using length as centimeter only. So if we use kappa dash, or kappa dash, that is equal to 1 by 520 into 1.29 divided by molarity is equal to 0.2 m into 1000. So if we divide this one by this one, this is going to be equal to 4, this one, 10 is multiplied above, so this is going to be equal to 1000 divided by 104 into 1.29 Simon centimeter square mole inverse. This is the data given, Simon centimeter square mole inverse. And if we convert this, I am using this is as I am using this one and I am using this one 1.04. This is the data. I have used 10 divided by 1.04 and 1.04 into 1.29. Now if we convert this one in meter square, then that will be equal to lambda dash m will be equal to 10 divided by 1.04 into 1.29. 1.04 into 1.29. You can see the relationship. If we have done some calculation mistake, then you can see that R is equal to rho L by A, that is equal to R by kappa. So this is incorrect, I think. L by A is equal to 1.29 centimeter inverse. L by A is equal to 1.29 also, because kappa will be multiplied here. So 1.29 this is, and if this is 1.29, so this will be going to divide here, and if we divide itself, so it will be equal to 1.29 divided by this one. So this is 1.29 will be upside, and if it is 1.29, so 1.29 will be upside. So if we use this one 1.29, so this is 12.9 into 10 to the power 4 Simon meter square mole inverse. In this way you will have 12.4 into 10 to the power 4 Simon meter square mole inverse. So this is the correct result. You have, in this question we only have to do this. From first data we have to calculate cell constant, and this cell constant data is kept in second solution, because cell is taken as same cell is taken, so cell constant will be same. Cell constant, if we have put, then lambda, then rho dash resistivity can be calculated. From rho dash we have calculated kappa dash, and from kappa dash we have calculated lambda m dash. So this is the concept. From first data we have to calculate cell constant, and in next data from resistance we can calculate by using cell constant that we have calculated in previous step. We can calculate resistivity and conductivity, and from that one molar conductance can be calculated. The next question that was asked by JEE Main is question number 25. Lambda equivalent of CS3COONA is equal to 91.0 Simon centimeter square equivalent inverse. Lambda SCL is equal to 426.2 Simon centimeter square equivalent inverse at 25 degrees Celsius. What additional information one need to calculate lambda infinity equivalent for acetic acid? A option is lambda infinity of equivalent of Cl CH2 COOH. B option is lambda infinity of NaCl. C option is lambda infinity of CH3 COOK. This is equivalent conductance. All is equivalent conductance. And D option is lambda infinity H plus. This was the question asked by JEE Main in 2007. From this question you can easily see that the correct answer will be lambda equivalent of NaCl. If we have to calculate lambda equivalent of CH3COOH, then you will require lambda equivalent of CH3COONA plus lambda infinity equivalent of HCl minus lambda equivalent of NaCl. So this is the data that we require to calculate lambda equivalent of CH3COOH. So this is the 25th question that was asked by JEE Main in 2007. The next question that was asked by JEE Main is question number 26. In this question it is told that the cell zinc 2 plus, that is 1m, and copper 2 plus 1m copper. E note cell standard condition, it is given 1.10 volt, was allowed to be completely discharged, discharged at 298 Kelvin. The relative concentration of zinc 2 plus to copper 2 plus at final discharge condition, is A option is 9.65 10 to the power 4, B option is anti-log of 24.08, C option is 37.3, and D option is 10 to the power 37.3. These are 4 options given. This was the question asked by JEE Main in 2007. When cell is completely discharged, we can calculate the relative concentration of zinc 2 plus and copper 2 plus at that condition as follows. When cell is completely discharged, it means that E cell is going to be equal to 0. So E cell will be equal to 0, means E naught cell minus 0.0591 at 298 Kelvin, it is given, divided by n log, that is equal to reaction is equal to copper 2 plus concentration divided by copper 2 plus concentration. We have been asked zinc 2 plus divided by copper 2 plus, and zinc 2 plus concentration is going to be equal to zinc is oxidizing. This is, if we write the reaction, zinc 2 plus is upper side and copper 2 plus is lower side, is equal to 0. This is 1.10 volt minus 0.0591 divided by 2 log zinc 2 plus divided by copper 2 plus is equal to 0. So log zinc 2 plus divided by copper 2 plus will be going to be equal to 2.20 volt divided by 0.0591, and by calculating this one we will have 37.3. It means that zinc 2 plus divided by copper 2 plus will be going to be equal to 10 to the power 37.3. This is the data, this is the correct option. The point at which cell is completely discharged will have zinc 2 plus to copper 2 plus ratio is equal to 10 to the power 37.3. This is the question asked by JEE Main in 2007. Next question that was asked by JEE Main, question number 27. In this question is given that E naught chromium 3 plus chromium is equal to minus 7.02 volt, 72 volt, and E naught Fe2 plus Fe is equal to minus 0.42 volt. The potential of the cell, Cr3 plus 0.1 m, Fe2 plus 0.01 m Fe is, A option is 0.26 volt, B option is 0.336 volt, C option is minus 0.339 volt, and D option is 0.26 volt. This is question asked in 2008. We have to calculate EMF of the cell at this condition. So first we have to write the cell reaction. Chromium is oxidizing to Cr3 plus 3 electron. Fe2 plus is reducing by taking 2 electron to Fe. And if we have to add, we have to multiply 3 by and we have to multiply 2 here. You will have 2 chromium plus 3 Fe2 plus gives 2 Cr3 plus 3 Fe. If you look at the Q value, this is Cr3 plus to the square divided by Fe2 plus to the power 3. And now Cr3 plus concentration is given as 0.1 to the power 2 and this is given as 0.01 to the power 3. That's a 10 to the power minus 2, 10 to the power minus 6 and that will equal to 10 to the power 4. So we have calculated Q. N value you can easily see that number of electron transferred is 6 multiplied. After multiplication you have to calculate, this is 6. So E naught cell again. E naught cell is going to be equal to E naught. Reduction is happening to iron. So reduction potential of iron plus oxidation potential of chromium, which is oxidizing that species, that electrode that is oxidizing, we have to take oxidation potential, and that one is reducing, we have to take reduction potential. So reduction potential is minus 0.42 volt and oxidation potential will be equal to plus 0.72 volt, that is equal to 0.30 volt. So now we can calculate E cell is equal to E naught cell minus 0.0591 divided by N log Q. In this way we have 0.30 volt minus 0. We can approximately say it as 0.06 divided by 6 and log 10 to the power 4. So 0.30 volt, that is equal to 0.01 multiplied by 4, 0.04 volt, that is equal to 0.26 volt. So A is the correct result. You can easily see that. This was a question asked by JEE Main in 2008. So in this way we have solved some problems of electrochemistry that was asked by JEE Main. In next class we will solve some more problems of electrochemistry that was asked by JEE Main.